blossoming all over the world. And Sumoud, can you go to the next slide, please? Yes. Whether we like it or not, we are all in a space connected generation. We carry a bit of space in our pockets today because the mobile that you carry in one way or other is connected to space. I'm sure we all watch the television programs and especially the World Cup these days. Now, little do you know that what enables the television program to come onto your mobiles is nothing but a constellation of satellites that provides a hidden plumbing for that particular data or to come live to your uh, mobile phones or onto your television. I'm sure you must have seen whenever there is a live event happening, you will find a van with a dish. Now, that van with the dish is actually uplinking the program or whatever is live that is being telecast to the satellites. And from the satellites, the entire distribution of the content is happening around the world. So whether you are the live program is happening in Doha, Qatar, you can watch it in India or in the US or in Australia, anywhere in the world instantaneously, just because it is being provided by the satellites. Another technology that you carry in your mobile is something called as the GPS chip, which is a global positioning system chip that is on your phone that communicates with the mobile network and that in turn communicates with the satellites to provide the exact location of where you are. So all the hyperlocal apps, whether it's a Google Maps or a Swiggy or a Zomato or a Uber, uses this particular GPS technology. But we take it for granted. And I always say the space or the satellites is the hidden plumbing, just like water. You know, when you open the tap, you expect water to be available. So today, when you open your phone, you expect data to be available. But little do we want to know what is enabling water to come to our taps, the hidden plumbing, the pipeline that brings the water to your tap. We take it for granted. Till such time we are in a shower and the water stops, then you wonder what happened to the plumbing. And similarly, whenever there is an internet outage, that's the only time we talk about, what is the plumbing that enables data. Then you suddenly read there's a fiber cable cut or there is a satellite that has gone out of service. So you're not able to get the live data coming onto your phones. Similarly for weather or financial services. So in the US alone, data or satellites and satellite driven data drives around 5 trillion of economic activity. So this is very, very significant for us, all of us to understand that data is enabled by satellites. That means the space industry is very critical for us to use data. Next slide. Now, one thing that is happening in space is the space in the earlier days used to be dominated by big satellites. Now, the big satellites that you have were of this 3 tons and above. They were around 6.5 tons. And they used to be the height of 4 people, that is 24 feet, 6 feet into 4, 24 feet tall, around 2 people wide, and maybe 2 people depth of these satellites. And these satellites used to carry transponders. So big satellites used to carry hundreds of transponders. And these transponders is what you normally give to your customers. But if you look at, and these big satellites takes 2 years from a design to launch, and they're built for a lifespan of 15 to 20 years. Now, one thing that you need to realize is a satellite is nothing but a communication device like your phone, right? Because it picks up signals, it sends signals, it picks up images, it sends images. Now, if your phone is getting obsolete in less than 6 months, imagine what happens to a satellite that is built for 25 years. The technology becomes obsolete so fast these days. So eventually, after 4 to 5 years, it becomes a brick in space. Now, as a result of which, the entire philosophy of space is moving towards building smaller satellites. So now the new constellation of satellites, so instead of sending one big satellite with a constellation, no, you will send up a constellation of 120 satellites, and you will launch 10 satellites in this month. Maybe 6 months down the line, you will send the next 10 satellites. But the next 10 satellites that you send will be the next generation of satellites that you're sending. This is like launching an iPhone 9 and 10. So satellite companies are going to become like telecom company or phone companies who have to innovate to bring in the latest technology out there into space. And that is where this is evolving. Sumoud, next slide, please. And
Sumoud, the slide is not changing here.
Yeah, there's some delay. Sorry, just a minute.
Okay, so you see the evolution of the small satellite launches with around 2-3 small satellites in 2012. It is in 2021, there was around 1,743 small satellites being launched. So the small satellite is evolving. Now, not only this, the next slide, Samu. From there, the space is not only about small satellites. Now, the small satellites lead to small satellite launch vehicles, or what we call as the launch vehicles itself. So earlier we used to have the GSLVs, which were designed to carry the PSLVs, and the GSLVs are designed to carry the big satellites, which are about 3 tons. Now with small satellites coming up, you don't need a big vehicle to carry a small satellite. Or like what you have in Falcon 9 or SpaceX of Elon Musk. No, his one launch vehicle will carry maybe 200 satellites at one go or 150 satellites at one go. So launch vehicles, because of the small satellite and small launch vehicles, there are around 160 plus companies around the world building launch vehicles. There are around 14 plus companies working on sending people to the space. So you must have read recent articles about Amazon founder Jeff Bezos going to the edge of space in his own Origin, that particular spacecraft. You have got a crew module from SpaceX called as a Crew Dragon, taking astronauts to the International Space Station. You had Richard Branson of Virgin Group also taking his spacecraft to the edge of space and coming back. So the space tourism and sending human missions to Moon and to Mars are programs that are evolving. And in fact, we ourselves have got the Gaganyaan program, which is again the human space flight program of ISRO, that is going to do the first flights, of the launch vehicle testing. So some test crafts being sent up by 2023-24 timeframes. And then NASA has got a program called as the Artemis program to send people back to the moon by 2027. And that is called the Artemis 2 program. And they have got both cargo lander as well as the human lander programs. And then, of course, there are landers, rovers, and orbiters. So the space is evolving. And from a $469 billion space industry globally, Goldman Sachs forecasts that by 2040, it will be a $3 trillion industry. So you will see the opportunities for career opportunities for all of you who might be interested in getting into a master's in space technology. And this would be the right time to launch your careers into space. Next slide, Sumoud. And as I mentioned, the space is entering its fourth evolution. So one thing that you would see is that earlier we had only 6 countries or regions that had global space expertise. So it was US, Russia, China, Japan, Europe, and India. So there are only 6 countries which today we call as the spacefaring countries, right? The spacefaring countries were only 6. So the first evolution was before the 1950s. There was the early study of astronomy and physics that used to happen. That was Space 1.0. The Space 2.0 was the spacefaring nations engaging in space race, leading to the Apollo moon landings in 1969. That was a time frame between 1950 and 1969. And that's when the Neil Armstrong and all that went to Mars, to the moon, and land the first human landing on the moon. And then you have got Space 3.0, which is from 1970 to today, which is like the International Space Station was conceived, all countries participating into building that particular International Space Station, sending astronauts into the International Space Station, doing a lot of scientific research on the space station. And at the same time, the collaboration or cooperation was restricted to a few countries only. But then you saw other countries like India, we launching our own space programs. And today, India is one of the few countries that has got a 60 years of experience or 6 decades of experience in space industry. So the new evolution of space, the space 4.0 that we are witnessing, is over and above these 6 countries. So that means these 6 countries had the government space agencies driving the space program. So you had ISRO, you had NASA, European Space Agency, you had the Japanese space agency called JAXA. They were driving the space technology investment as well as the space programs. But now in space 4.0, you have the private companies coming in like the SpaceX, or Virgin Galactic, and Jeff Bezos companies, all of them coming in, Blue Origin. They're all coming in and trying to participate in the global space programs. And then there is industry participation, colleges participating in this particular space 4.0. And then it is becoming more and more inclusive. So it is easier for companies to go and set up private space programs. And we ourselves are designing satellites. We would like to launch our first satellite in 2024. And we are already contributing to the launch vehicles. Pradeep, our CTO, will speak about that, about the various programs that we have with regard to the launch vehicles, satellites, and the space debris management, as well as our participation in the lunar lander programs in the US. Just to tell you that the space 4.0 opens up a lot of avenues for career development in the space sector. Next slide, Sumoud. Yeah. And the other important thing is that when we speak about the 3 trillion or the 4 trillion, what are the various sectors in space? For example, you will have, in order to launch anything into space, you need to have a launch vehicle. So there's, as I mentioned, there are 160 types of, there's 160 plus companies working on building launch vehicles. Now, once you send the launch vehicles, you send up first has been satellites, which are used for Earth observation, which provides the mapping of the Earth to provide precision agriculture, national security, and a lot of other use cases as well. Now, even the SpaceX's Starlink program is trying to provide satellite-based broadband connectivity to homes or to individual phones as well. Then you have got the satellite communications of broadband and IoT. And then you have got satellite navigation, which is essentially smart transportation in space. And then you have got the emerging sectors, which are the human space flight programs, which are the suborbital flights, which was done by Richard Branson and Jeff Bezos. Those are called as the suborbital flights. And then the crew transportation, transporting people to international space stations, to the moon, to Mars, and all that. And then the tourism. And then again, the emerging space activities will be with regard to habitats, like setting up colonies in Moon and Mars, mining for space resources, orbital services like, you'll land the satellite in one orbit, and there is a tug, a space tug that will pull this particular satellite from this orbit to the other orbit. So there will be orbital services, or there are also companies talking about manufacturing in space. Can we manufacture a satellite in space rather than launching a satellite from Earth to space? So there will be orbital services as well as space debris removal. As more and more launches happen, there will be a lot of litter in space. What can we do to identify and manage that particular space debris? And then you talk about the science and the space exploration missions. About, you must have read about satellites moving very close to the sun, and that particular spacecraft moving very close to the sun to provide us more and more information about what is sun, or what is that particular planet, or There are recently, you must have heard about a NASA satellite going and crashing onto an asteroid, so that this particular asteroid, we are able to understand, so that tomorrow, if the asteroid should come towards closer to the Earth, how can we manage, to mitigate that particular risk of that crashing onto the Earth? So, a lot of space and space exploration mission about observation and exploration science is another opportunity for career development in space as well. Yeah. And just give you a bit of NASA's human space flight program, as I spoke about the Artemis program too. So they had the International Space Station. So this was in the before 2018, low Earth capability from 2000 onwards. Then they had the Artemis 1, which was in 2010. Then they built this Orion spacecraft, which is built in 2020. And then small commercial landers have been, NASA has been spending a lot of money encouraging private companies to do launch programs to the lunar surface. And in fact, we are working with one of the companies called as Orbit Beyond with regard to their lunar lander program. And then there are, by 2022, they said they will do mid-size robotic landers. And then in 2026, they will have a satellite gateway, which will communicate like a relay communication between the lunar surface to the satellite, and from satellite to the ground station on the Earth. And then advanced exploration landers are planned for 2026-27, and sooner or later, between 2026 and 2030, you will see more and more habitations coming in on the lunar surface, and more human missions happening onto the lunar surface. Now, I will leave from here, I will leave it to Pradeep to talk to you about the Indian programs, and also to talk specifically about launch vehicles, as well as to talk about satellites. And Pradeep is our Chief Technology Officer, a decorated space veteran in Indian Space Research Organization, where he spent 39 years. And anything that you see flying from Indian space program, whether it's a launch vehicle or a satellite, he would have had his contribution to these programs. So please welcome Pradeep, our CTO, and Pradeep will take over from here. Thank you very much.
Thank you, Sheju, for giving very vivid description of space activities in a very, very short time. So you have already explained about the need of that. So I'll just say what is happening in ISRO. In ISRO now we say that we are having a Gaganyaan mission which is being talked for the last 2-3 years, and very soon it may go there. So now you can see the Gaganyaan mission, we will take human up. There will be 3 astronauts. They will be taking round of Earth for 3 rounds. See, it's not question of why we go there. Question is, with this, we will be building up our own space capability to go up. And as it is shown in this slide on the right side, this is the launch vehicle which is used for taking the satellite. This Gaganyaan. Gaganyaan also will be like a satellite. It will go up. Then all the top portion which you can see where the crew module is there, that alone will be coming back. And when it comes down, you can see a lot of tiles sort of things are there on that, which has to sort of resist the frictional heat when it comes back to Earth. I think, can we go to the next slide, Sumoud? Okay, now we'll see that. Now I'm just coming to the launch vehicle side. See, just now, what was explained by Sheju, we are having various types of missions, various types of satellites. And these satellites can go in the low Earth orbit, middle Earth orbit. It can go to geostationary orbit. I think geostationary orbit is one very interesting orbit where the satellite revolves around the Earth at the same speed as Earth revolves about its own axis. So as a result, it is like 2 vehicles going on the same speed parallel to each other, and they look stationary to each other. So that's why we say that it is geostationary satellite. So here, various type of, you can see various types of payloads which we have told, low LEO means low Earth orbit, GTO, geostationary transfer orbit. Then comes furthermore the telescopic and all is there. So we are having 3-4 types of orbits for which, depending upon a launch vehicle which can take a particular component, a particular satellite in a low Earth orbit. Let us say if it can take 1.2 tons, like our PSLV. When it comes to the lunar, the same thing was used for the lunar mission. That time it could take only some 150 kg to the lunar mission. That was the first Chandrayaan which we had long, maybe some in around 2011 or 12. So that way you can see the various types of launch vehicles are made by various agencies here, and that also depends upon the main source is the thrusting sources. What is the thrusting sources which we have? So that decides how much height we can go, how much satellite we can. I think some of you must have studied about escape velocity. We have to cross the escape velocity and go to the next mission. So these are the various types of satellite which is listed here. So can you go to the next slide? This is there for ISRO. This is because all the audience here is all from India. So these are the things you must have seen. We had first successful flight of SLV-3 that was long back in 1980s. Then once we had the successful SLV, we had a satellite of the mass of some 40 kg in a low Earth orbit. Then when we had a successful mission, then to the lower stage of the SLV-3, we have attached 2 more to that main vehicle, and we say augmented satellite launch vehicle. This was the one which could carry a weight of around satellite around 150 kg. Then we straight away went to the PSLV. That was something very new jump from the side, from the ISRO side, where straight away we have gone to polar satellite. It goes pole to PSLV means polar satellite launch vehicle. It goes from North Pole to South Pole. Here we had a capacity of around 1,200 kg in the orbit of 700 kilometers. Next we had, till that time we had very small liquid engine which was sitting in the 4th stage of the PSLV. Then we had multiple, and the 2nd stage of the PSLV also. But when we augmented, like, SLV to ASLV, same as PSLV, when we went to GSLV, we put in 4 liquid engines strap in the bottom stage, lower stage. And this made it to take a geostationary transfer orbit, GTO. GTO is 180 kilometer by 36,000 kilometer, and where finally the satellite has to go and sit. And in GTO, we could give around 1.2 ton, 1,200 kgs. Latest one which we are having, the heaviest vehicle which ISRO has, is GSLV Mark III, which is in a position to carry around 4 tons of payload or satellite in the lower Earth orbit. And the same thing is planned for the Gaganyaan mission also. Same vehicle was planned to carry our this Chandrayaan 2. So these are the various vehicles which we are having. And I'll just give you a small description about this vehicle. Can you go to the next slide, Sumoud? See, when we talk of vehicle, now you see so many elements are there. Starting from bottom to top, if you go, first we should have a thrusting source where the main body is there for the which is lower stage. To get additional thrusting, we attach some strap-ons. Here you can see that left hand there are 2 strap-ons attached. These strap-ons gives the additional thrust. Then we have some sort of interstage to attach the lower stage with the upper stage. Then in this one, whatever vehicle we have explained, there is one liquid stage coming over there. Then on top of that liquid stage, then we have one more smaller stage we have. So what I mean is, this is a typical launch vehicle configuration. A launch vehicle will consist of first the thrusting phases, And there is one very interesting term, I think you may not be knowing, there is something called specific impulse. That is the thrust per unit mass burnt. So that is something which is a very good parameter where which is taken in launch vehicle design. So I should have very high specific impulse where the thrust per unit mass burnt is quite high. So there only, like for solid motors, we have some specific impulse. Let us say 1 unit is called second, like 280 seconds. When you go to liquid, it goes to around 300 seconds. Then we go to cryogenic, it goes as high as 650 seconds. So there are, so that's why you must have seen cryogenic stage, we try to put on the topmost stage of the vehicle. And then we have the liquid stage, then bottom we have the solid state. But this is a typical configuration based upon the what sort of mission we take it forward. So one more thing I want to stress upon is a launch vehicle is a system which involves all branches of engineering. It can be electrical, mechanical, chemical, and control system, electronics, because we have to have a communication from the ground. So any whatever metallurgical material selection, so whatever branches of engineering we say, everything is used in realizing a launch vehicle. In the same way satellite also, because they don't not something, they are called, they will be called as a system. And here only the concept of systems engineering comes here. So if somebody does MTech in space sciences, they will be told about how a system should work. Can we go to the next one? Next slide. Yeah, now here you see that like launch vehicle, this is satellite. The satellite consists of the solar cells. There are here, what are the various things we are using? Electronics, propulsion, and then control system. Then even the communication system has to be very, very strong. You are communicating with the system with the away lakhs and kilometers away, and then you are talking to that. So as I told, this launch vehicle, the same way satellite also, it is a combination. They are all called, they will be called as a system, because once we design these systems, every branch of engineering has to be used. Even it has to survive the vibrations generated during flight. So we have to have a good structural expert who should analyze what sort of vibration is coming, how the things will be, how we can take care of that in design. And then there are some places where we have, like, this human in space, where the satellite comes down to Earth, because that time it has to survive that heat generated. So you talk of any branch of engineering, it's all utilized. And when you go for space sciences, it is I tell you, a real blend of all the branches which we have studied of engineering. And it will be really useful for anybody who comes for this sort of course, because they will be really exposed to the total system. Yes, Sumoud?
Yeah. Thank you. Thanks. Yeah. Thanks to hear from you, Pradeep ji. All right.
Thank you, sir.
Yeah. Now Sumoud will take you forward for the further activities, how the career growth and all will happen in the field of launch vehicles, or in the field of space sciences. So over to Sumoud, please.
Thank you. Thanks, Pradeep ji. Hi, good afternoon, everyone. I'm Sumoud Kurup. I'm currently responsible for business development at AADYAH. I'm personally a aeronautical engineer who started, its studies and career specifically in Bangalore itself. So a lot of things that you could relate to. I have moved from aeronautical to defense to space. So these are the sectors mostly. I think a lot of engineers who are inspiring currently towards the final year, or somebody looking at what you should be moving ahead to, or what path you should be taking. A lot of tremendous opportunities out there in the market today. Typically, talking about space, it's an era of new space, as Shaju was mentioning in his earlier slides, and we believe that when any new industry is being formed or reformed specifically in a region, it's a complete ecosystem that develops along with the industry. So this is a quick slide which shows how the ecosystem of the current space companies is lying down. So you earlier days, you only had government organizations like JAXA, ISRO, NASA, or ESA who were taking up the space science or space technology activities. From there, with the new space revolution, you see that there are a lot of R&D hubs and associations, research driven by institutions, incubation centers being formed on those research institutions, each incubation being supported by initial level investors, these companies maturing it into startups, and also big players in the industry stepping in, taking the development of space systems. So currently today, we can say that there is a whole ecosystem of space spread across multiple verticals, which is pretty much matured. We always keep saying that it is like the telecom industry in 1990s, earlier days. I don't know how much of you could relate to this, but we used to have land phones where you use STD booths or so much to make calls. It used to be pretty expensive in those days. And from there, today we talk about 3G, 4G, 5G connections, wherein all communication is in your phone pocket. You have free data or data available for very less cost, which is available. So that has that evolution has happened over the period of 10 years. And today, space is under the same race, and the ecosystem of that is currently what is available today, as you see. Now, I thought it will be great to jot down a specific case study which was presented by ESA, or a European Space Agency, on what would be a typical career path specifically for an engineer to enter into a space program. I personally like this case study, so I thought I should present it to the audience today. So if you look at the easiest access, which ESA says is, upon a master level with a specific work experience, you directly get into the space programs. In what verticals, I'll show you in the coming slides. But there are entries available in multiple ways, starting from a master level to a bachelor level to a PhD. And the best part is that today, with the ecosystem being developed in India, you have multiple private companies, couple of them to name with, like us, AADYAH Aerospace. We do lie a bit low in the market, not doing a lot of PR activities of what we do, but we currently work with more than 5 launch vehicle companies across the globe in doing their thrust vector control system with the guidance of Pradeep, whom you were listening to. We support a lot of satellite programs in making avionics and electronic systems for the satellites, like control units, power distribution systems, guidance systems, and so on. We have our own satellite program, wherein we are building satellites in collaboration with Israeli Innovation Authority to support agri and IoT communications in a lot of prospects. And we have some programs on space situational awareness as well. So similar to AADYAH Aerospace, you must be hearing the launch vehicle program of Skyroot. They recently had a very successful, suborbital launch happened last month. Agnikul is still in the next phase of proving their technologies on having a successful launch, probably wishing them all the best again. If you look at on satellite fronts, we have companies who are doing propulsion systems like Bellatrix, Manastu. We have other satellite programs who are doing a lot of surveys like SatSure and so on. So there are numerous opportunities which are available specifically in India itself. Specifically, if you want to have a kind of an internship, incubated programs, or even get experience and then come and work for these space programs in India. And I think that is definitely a huge opportunity which is opened to the current generation which is out there, and you should definitely consider and explore, because as I keep saying, my team, if space doesn't excite you, I don't know what would excite. I think that is the most exciting thing what I personally have seen in my life, and being a part of it would be amazing. A quick slide on how the specific industry is jotted down. So it's not that you know when somebody talks of space, I want to be an astronaut, or I would do an astrophysics or something. But ecosystem is built by multiple people, wherein you have people from finance, you have people from materials, you have people from procurement, sales, engineers, scientists, everybody coming in together in building that specific, complete business. So as per ESA split, a typical space program would consist of around 45% of engineers and analysts, around 7% of scientists, 12% of managers, a couple of them coming in from management support functions, and a couple of them coming in from admin and technical services staff. So, specifically, it is not that you have started your career as engineers. You might have entrepreneurs in this group. You might have people who are good at management in this group. And there are people who must be good at multiple ways, specifically in propulsion, specifically in orbital planning, mission planning. Some people who say that I only want to do structures. So you need to find your niche, and there is space for everybody in this ecosystem is what I was coming up to. So, happy to now hear from everybody from the audience and know what kind of thought process that you have. Just before I conclude, a quick segregation that I also thought of, wherein you could choose your path, specifically speaking about engineers. What I would say, if you look at where should your core interest be lying, so today we see a huge scope of computer engineers who are doing softwares for a lot of these systems on board and even the ground stations. Material engineers, specifically, a lot of activities happening on in orbit or in space manufacturing, what kind of materials you want to use, and so on. Robotics is a very common term that I can put in, but that in itself is a multiple, uh, uh, you know, uh, streams coming in together of electronics, mechanical, embedded systems, sensors, and so on. And definitely spacecraft engineers who look at the structural design and integrity of the whole vehicle. Now, with these engineering streams, you address the multiple technologies which are available, and that's how you build the whole space capability today. So happy to hear from everybody in the audience. If should you have any questions on the industry, on what path to choose, where the market is heading, or some technocrats who want to do things on your own, happy to be associated with you. All support from ADYPU and AADYAH on taking your dreams true. Thank you. Thanks a lot.
Thank you, Sumoud, for an interesting session. We have one question coming up from one of our participants, Abdul Sharon. He is asking further details about nuclear space propulsions.
See, till now in launch vehicle propulsion system, we have gone up to the solid fuel, liquid fuel, and cryogenic fuel. Nuclear is only in the labs. Maybe it will come out after some time. As of now, we don't have any launch vehicle using the nuclear fuel as of now. Yeah.
Thank you, sir, for your response. Right now, we don't have any further questions coming up, but if we receive them, we will share with you so that
Sure.
We can satisfy their inquiry. So I would be sharing one presentation, just one slide to conclude this webinar about our Masters in Space Technology program. So yeah, so all our participants are mostly from engineering backgrounds and in the final years of their course. So so to begin with, we don't have many master's program in our country in area of space technology. The MSc programs that you can see, they are available in either Europe or the UK or the US. Our country, we have couple of programs by public institutions, but from a but this program coming from a private university is the first in our country. So I have tried to show here few of the highlights of this program. So this is a 2-year full-time program that will be undertaken in Pune, in our Pune campus, as well as our with our industry partner AADYAH Aerospace in Bangalore. So and we have program leaders and advisors from reputed global universities. The curriculum had been designed by in consultation with the industry to cater the growing demand of space tech professionals in our country. And we have recently started our classes for this program. And for the second batch, we have opened our admissions. So please feel free to contact us through these coordinates, and we would be happy to answer any of your queries. Thanks for our industry partner experts, Saju sir, Pradeep sir, and Sumud. So it was very nice of you to take some time out for this interesting webinar, and hope we will have one soon in next year.
Okay.
All right. Thank you, Avinash. Thanks, everybody. All the best. Thank you. Bye-bye.
Thank you.